This is SpaceTime, Series 28, Episode 150, for broadcast on the 22nd of December, 2025. Coming up on SpaceTime, the deadly embrace of three dying stars. Claims Saturn's biggest moon, Titan, might not have an underground ocean after all. And NASA's missing maven spacecraft still silent. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers are unravelling the mysteries of a distant star system where three massive stars are locked in a 190 Earth-year orbit, in the process creating spectacular spirals of cosmic dust. The findings, reported in the Astrophysical Journal, show four spectacular dust shells spiralling outwards from three massive stars locked in a cosmic dance. The rare stellar system, called Apep, is located more than 8,000 light-years away in the constellation Norma, named after a serpent deity from Egyptian mythology. Apep consists of a Wolf-Rayet binary star system and a hot blue supergiant. Now, Wolf-Rayets are a very rare class of massive stars, in which some of the earliest carbon in the universe is forged. Only 1,000 Wolf-Rayet stars are estimated to exist in our Milky Way galaxy, a galaxy that contains literally hundreds of billions of stars. Of the few hundred Wolf-Rayet binaries that have been observed, Apep is the only example that contains two Wolf-Rayet stars in our galaxy. Using NASA's Webb Space Telescope, together with data from the Very Large Telescope, the VLT, in Chile, the study's authors obtained extraordinary images of this rare system displaying four distinct shells of dust. One of the study's authors, Ryan White from Macquarie University, says the discovery helps astronomers better understand how stars like this interact and how they evolve over centuries. White and colleagues combine precise measurements of the ring location from Webb images, together with the speed of the shell's expansion from observations taken by the VLT over 8 years. This is a one-of-a-kind star system with an extremely long orbital period. In fact, the next longest orbit for a dusty Wolf-Rayet binary is around 30 Earth-years, and most have orbits between 2 and 10 Earth-years. Observations of this system taken prior to Webb only detected one shell. While the existence of the outer shells was hypothesized, ground-based telescopes were simply unable to uncover any. And that's where Webb comes in. The Webb image, combined with several years of data from the European Southern Observatory's Very Large Telescope, was able to narrow down how often the pair swung around each other, roughly every 190 Earth-years. And over each incredibly long orbit, the stars pass closely together for just 25 Earth-years. And it's during these relatively short periods of time that they were able to create their clouds of dust. Webb also confirmed that as well as the binary Wolf-Rayet pair, there's a third star in the system, a massive spectral type O-class blue supergiant. And that dust ejected by the two Wolf-Rayet stars is slashed by the third star, carving a hole into each expanding cloud of dust from its wider orbit. The authors were able to refine the orbits of the Wolf-Rayet binaries by combining precise measurements of the ring location from the Webb images with the speed of the shell's expansion based on the observations taken by the VLT over 8 years. The dust-producing Wolf-Rayet stars in Apep aren't exactly on a tranquil cruise. They're whipping through space and sending out dust at around 2,000 to 3,000 kilometers per second. When the two Wolf-Rayet stars approach each other, their strong stellar winds collide and mix, forming and casting out heaps of carbon-rich dust for a quarter of a century at a time. And that dust is also very dense. The specific makeup of the dust is another reason why Webb was able to observe so much more. That's because it largely consists of amorphous carbon. Carbon dust grains retain higher temperatures even when they're spreading far away from their progenitor star. Now, while these exceptionally tiny dust grains are considered warm in terms of space, the light they emit is still extremely faint, which is why it could only be detected from space using Webb's mid-infrared instrument. The authors believe the two Wolf-Rayet stars were initially far more massive than their supergiant companion, but over the years they've shed most of their mass. It's now likely that both Wolf-Rayet stars are between 10 and 20 times the mass of the Sun, while their companion supergiant is 40 to 50 times the Sun's mass. As for the future, well, Ryan White says eventually the two Wolf-Rayet stars will explode as supernovae, quickly throwing their contents into space. And he admits that either one or both of these Wolf-Rayets may also eventually produce a gamma-ray burst, one of the most powerful events in the universe, before ultimately collapsing down to become stellar mass black holes.
So a Wolf-Rayet star is the very end of life stages of the most massive stars. So stars that are born with masses more than about 25 or 30 times the mass of our own sun. They go through their lives combining hydrogen into helium in their core, and then once they've run out of hydrogen, they combine helium into carbon, nitrogen, oxygen, etc. And eventually when these stars kind of start burning through all of their fuel, they get rid of their outer layers, and they're essentially a purely helium, carbon, nitrogen star. So they get rid of most of their mass. They're incredibly bright. They have extremely strong stellar winds, and they live for just a blisteringly short amount of time. So for reference, our sun will live for about 10 billion years. And these Wolf-Rayet stars, they spend about 100,000 years in this Wolf-Rayet stage. And the total star's life is about 1 million to a few million years.
The James Deans of the stellar world.
Yes, exactly.
So these are big O and B type stars that have reached the end of their lives. They're pumping huge amounts of carbon into space. And in this case, there are two of them.
Exactly, yeah. So it's the only system we know of, the Apep system, that has not one but two of these classical Wolf-Rayet stars at the same time. It's the only system we've found in the universe that's like this, and we don't really know why it's like that, but it's a very interesting system.
And they have a northern companion as well, another large star.
Exactly, yeah. So I was very lucky to lead one of our team's papers on this system with our new, very beautiful James Webb Space Telescope image. And one of the main things I found was that there is this third O-type supergiant star as a part of the Apep system as well. So it's reasonably far away from the two Wolf-Rayet stars. You can kind of think of it like the two Wolf-Rayet stars are happily orbiting around each other, and there's this third supergiant star a stone's throw away. But we found that we conclusively linked this third supergiant star as part of the system through its effects on this beautiful nebula that the two Wolf-Rayet stars make. So it's the first time that we've seen this kind of nebula interaction in nature before from a third companion, and it really complicates our view of the system even more. So it's not just that there's two Wolf-Rayet stars in the system now, it's that it's actually a triple system as well, which just makes it really complicated.
I'm very scared that you're going to start talking about three-body problems there. That wasn't my forte.
Yeah. There's a lot of complicated three-body stuff happening here.
Now, these two stars, the two primary stars, they orbit each other roughly once every 190 years, but the key area is roughly a 25-year period when there's a lot of interaction going on in the form of the dust that's being expelled from both these bodies.
Exactly right, yeah. So the two Wolf-Rayet stars on this 190 orbit, I can't say this enough, it really is an extreme and very complicated system. It's by far the longest orbital period for this type of system. And these beautiful dust shells that we see are only made in about 25 years of that 190-year orbital period. So each of these Wolf-Rayet stars has their own extremely strong stellar wind, and they're on quite an elliptical orbit. So they spend most of their time quite far away from each other, but every 25 years, they kind of whip past each other in their orbit. And the conditions where their stellar winds collide are just right to form dust for those 25 years in particular. So you can kind of think about it as every 25 years, the system is throwing out a puff of smoke, essentially, which is quite unique for these systems as well. There are a couple of other of these Wolf-Rayet binaries that do episodically produce dust, we say, but most of them are kind of more constant producers of dust. So it really is an interesting system.
The dust is being pumped through the system at, 3,000 kilometers per second, some amazing speed like that.
Yeah, so
it must be giving you a great history lesson into the evolution of these systems.
Exactly, yeah. And that's one of the main reasons why we wanted James Webb imagery of the system is because we previously had an image of the Apep Nebula with the very large telescope, a ground-based 8-meter telescope in Chile, but it was only sensitive enough to see one shell of dust in the Apep Nebula. But with James Webb, we were able to see 4 shells. And so effectively that means that each time we're looking at a further out shell, we're effectively looking 200 years back in time. And so with this new James Webb image, we have essentially about 800 years of information about how these stars are moving, which has just been absolutely essential to nail down the orbit of the system and what it's been like over time. And it was really quite crucial to link that third star into the system as well.
That's Ryan White from Macquarie University, and this is SpaceTime. Still to come, a new study suggests that Saturn's largest moon, Titan, may not have a subsurface liquid water ocean after all. And mission managers at NASA are continuing efforts to try and restore communications with their missing maven spacecraft. All that and more still to come on SpaceTime. A new study claims that the Saturnian moon Titan probably doesn't have a vast underground liquid water ocean after all. The findings, reported in the journal Nature, contradict earlier studies which suggested that a liquid water ocean existed below the methane-covered world's surface. Titan is shrouded by a hazy atmosphere, and it's the only world in our solar system other than Earth where it rains. That rain forms streams and rivers, and they flow into lakes and seas. However, on Titan, the liquid isn't water, but methane and ethane. In fact, Titan's so cold, water there is frozen solid, forming bedrock. Now, a careful reanalysis of data from more than a decade ago indicates that a journey below Titan's frozen surface likely involves more ice giving way to slushy tunnels and pockets of meltwater near the rocky core. Data from NASA's Cassini mission to Saturn and its Huygens lander, which landed on the Titanian surface, initially led scientists to suspect a large ocean composed of liquid water lay deep beneath the ice. The problem is, when they modelled the moon with an ocean, the results didn't match the physical properties described by the data. And that's where this new study comes in. This fresh look has yielded new, slushier results. And they're important, because these findings could spark similar inquiries into other worlds in the solar system, and they could also help narrow down the search for life on Titan, if it ever had or does exist there. One of the study's authors, Patricia No from the University of Washington, says instead of an open ocean like the Earth, astronomers would probably find something more akin to Arctic sea ice and aquifers, and that would have implications for the types of life, if any, that might exist there. And it also poses questions about the availability of nutrients, energy, and so on. NASA's Cassini mission began in 1997 and lasted nearly 20 years, in the process producing volumes of data about Saturn and its 274 known moons. As Titan circled Saturn in its elliptical orbit, the authors observed the moon undergoing gravitational stretching and squeezing depending on where it was in its orbit in relation to Saturn. Back in 2008, scientists proposed that Titan must possess a huge ocean beneath its surface in order to allow for such significant deformation. Jeannot says the degree of deformation depends on Titan's internal structure. A deep ocean would permit the crust to flex more under Saturn's gravitational pull. But if Titan were entirely frozen, it wouldn't be able to deform very much at all. Now, the deformation detected during the initial analysis of Cassini mission data could have been compatible with a global ocean, but it now seems that isn't the full story. You see, the new study shows that Titan's shape-shifting lags about 15 hours behind the peak of Saturn's gravitational pull. It's a bit like a spoon stirring honey. It takes more energy to move a thick, viscous subsurface than it does liquid water. And measuring that delay told the authors of this study how much energy it takes to change Titan's shape. That allowed them to make inferences about the viscosity of the Titanian interior. The amount of energy dissipated was much greater than what would be expected in a global liquid water ocean scenario. So the model our authors are proposing instead features more slush and quite a bit less liquid water. Slush is thick enough to explain the lag, but it still contains water, enabling Titan to morph when tugged. Of course, the watery layer on Titan is so thick and the pressure so immense that the physics of water changes. Jeanette says on Titan, water and ice behave in a very different way to that of seawater here on Earth. Although the notion of an ocean on Titan invigorated the search for life there, the authors believe the new findings might actually improve the odds of finding it. Analysis indicates that the pockets of fresh water on Titan could reach 20 degrees Celsius, and any available nutrients would be more concentrated in a smaller volume of water compared to a huge open ocean, and that could facilitate the growth of any simple organisms which existed there. While it's unlikely scientists will discover fish wriggling through the slushy channels, if life is found on Titan, it may well resemble polar ecosystems right here on Earth. This is SpaceTime. Still to come, NASA's MAVEN mission remains silent, and later in the science report, paleontologists have discovered that some mosasaurs may well have hunted in rivers as well as seas. All that and more still to come on SpaceTime. NASA mission managers are continuing their efforts to try and restore contact with their missing MAVEN spacecraft. The Mars Atmosphere and Volatile Evolution spacecraft fell silent during a routine pass behind the red planet back on December the 6th. Engineers at NASA's Jet Propulsion Laboratory in Pasadena, California, have been reviewing the last data packages received before Mars occultation in order to try and determine what could have gone wrong. Only then will they be able to work out whether or not they can save the vehicle. Before the loss of signal, telemetry indicated that MAVEN subsystems were all operating nominally as it approached occultation. As MAVEN moved behind Mars, communications with NASA's Deep Space Network was always expected to cut off. But then mission managers failed to reacquire a downlink signal when the orbiter reappeared from behind the planet. Now, one possibility is that MAVEN may have defaulted into a safe mode, in the process changing its attitude or antenna positioning. That could have resulted in the probe's high-gain antenna becoming misaligned with the Earth, preventing normal communications. To try and resolve the issue, if that's the case, mission managers are now broadcasting continuous instructions to the spacecraft, in the hope that it may pick up part of the signal and re-establish contact. Now, the communications being sent includes a sequence of contingency commands that target known safe mode and attitude control recovery paths. MAVEN has been orbiting Mars for over a decade. It's studying how radiation in the solar wind strips atmosphere away from the red planet, a process which over billions of years has turned Mars from a warm, wet world with a thick atmosphere capable of supporting liquid water and therefore possibly life into the freeze-dried desert it's become today. MAVEN's also served as a key communications relay satellite, linking Mars surface missions like the Curiosity and Perseverance rovers with Earth. Other Mars orbiters, including the Mars Reconnaissance Orbiter, Odyssey, and the Mars Trace Gas Orbiter, are taking up the slack to keep science going down on the red planet's surface. But they're all a lot older than MAVEN, so it'd be nice to have it back. Needless to say, whatever happens, we'll keep you informed. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study of the 2022 Hunga Tonga eruption suggests that a gaseous seal created pressure in the volcano, acting like a cork, which eventually led to the massive explosion whose impact were felt worldwide. The findings, reported in the Journal of Volcanology and Geothermal Research, claim that the energy required to bring such a huge ash cloud from beneath the waves and into the atmosphere must have been comparable with the 1883 Krakatoa explosion in Indonesia. Now, if the authors are correct, this gas seal build-up trigger might be found in all plinian or explosive volcanic eruptions. And if that's true, it means early warning systems could be trained to detect a lack of leaking gases, suggesting that a build-up is underway and an explosion could take place. A new study has found shared genetic patterns across a range of common psychiatric disorders. The findings, reported in the journal Nature, found broad genetic patterns across 14 different psychiatric conditions, including schizophrenia, depression, and substance use disorders. The authors looked at the DNA from more than 1 million people, finding 5 key genetic factors that explain the majority of genetic variances in these disorders, and that could connect different sets of conditions. The authors say the new findings could help improve diagnosis and lead to new treatments. Paleontologists have uncovered a 66 million-year-old mosasaur tooth in North Dakota. The finding suggests that at least some mosasaurs may have hunted in rivers as well as the open sea. The discovery, reported in the journal BMC Zoology, may represent the first evidence of a mosasaur hunting freshwater prey in the Hell Creek Formation. Mosasaurs were giant aquatic lizard-like reptiles that grew to 12 metres or longer and lived during the age of dinosaurs. The authors propose that members of this mosasaur group may have been opportunistic predators, occupying a similar niche back then to modern-day saltwater crocodiles, that may have adapted to a freshwater environment in response to falling salt levels in the western interior seaway, gradually entering the river channels of Hell Creek as the seaway receded. A new study reported in the Journal of the American Medical Association claims that acupuncture treatment for lower back pain has resulted in greater improvement in physical function and reduced pain compared to patients who received conventional medical care alone. But as the skeptic's Tim Mendham points out, the study's left out some critical details, and those details prevent us from getting an accurate picture of the research or the amount of true scientific rigour involved.
This is a study done that was funded by the National Institute of Health in the US, in which they enrolled 800 people and looked at giving some acupuncture and some ordinary treatment, established treatments, and seeing the difference. And they were saying that those who had acupuncture at 3 months, 6 months, 12 months, feeling better about their lower back pain than those who are having ordinary treatments. Now, interesting starting point, and they're looking at older people, which is they reckon is a cohort that doesn't get studied a lot, and then they throw in a bit about acupuncture being a thing that's been around for a long, long time in the East. Point out a few issues. People with chronic back pain are desperate to get rid of it, absolutely, and anything they think will get rid of it, if they firmly believe, will make them feel better, because pain is as much an emotional and mental thing as it is a physical thing, and how you react, your threshold to pain and that sort of stuff. So therefore, you're getting people who are looking desperately for a treatment. They've probably been having medical treatment for years and they don't feel any better. So they enrolled 800 people. Now, this story, and this is where they have problems with it, they don't say how they enroll those people. Obviously, they've enrolled people with chronic back pain, lower back pain. Were they disenchanted people with medical treatment? Were they just people with back pain? Were they pro-alternative people? The story doesn't say. It doesn't say where they got the 800 participants. They say they enrolled them, but were these people volunteering themselves? And that impacts on the veracity of the results you get. If people are volunteering themselves, they tend to want a certain result. Then they say they treated some with acupuncture and some not. Normally, if you're doing an acupuncture test, you would have false acupuncture and real acupuncture. In other words, you have a needle.
There are certain spots where the needle's supposed to go, so the placebo would be to not use those spots.
That also, that's true. This is the meridian idea of the human body has all these sort of nerve lines through it, and there's so many meridian points that you have to stick a needle into, and the other ones you don't stick a needle into because it doesn't have the same effect. That's a bad start. There's no proof of this meridian system at all. The other thing is that there should be a placebo acupuncture, which is a thing where the needle actually goes into, like a false knife where in the movies, you stick something with a knife and the blade actually withdraws into the handle. So people think they're being jabbed with an acupuncture needle, but all they're feeling is the pressure, and the needle itself is not penetrating. Okay, so this story about this test doesn't talk about using placebo acupuncture as opposed to real acupuncture, as opposed to non-acupuncture treatments. So what you're suggesting is that these people are getting real acupuncture, are they? And that people who are coming to a test might be more inclined to want acupuncture and who are disenchanted with other treatments, and therefore they might be suggesting that their back pain is going because they want the treatment to work. And that's a major issue when you're doing a test of any sort of treatment like this, especially one which is sort of so emotionally based. And so if someone has other conditions, that you can probably test them probably pretty definitively. Testing pain is a hard one to do, and it's a matter of sort of getting big numbers, etc., and getting some sort of results over a large cohort of people, 800 people in this case. You don't know where they came from, you don't know how they got them, you don't know what their background is, at least as far as this particular summary goes. You don't know if they had false acupuncture treatment or real acupuncture treatment. Those who did, they should have had both to differentiate between real acupuncture and false acupuncture and placebo and or alternative treatments. Overall, the evidence for acupuncture is not good. And the background to it is not good. It might have been a traditional treatment in China and places like that over hundreds and hundreds of years. It was certainly promoted under Mao Zedong way back in the 60s and 70s as an alternative to Western treatment. I'm not suggesting that this is good Chinese stuff and therefore it's got thousands of years behind it. The idea was that because in China they couldn't get proper clinics to treat.
Yeah, but he used Western treatment, didn't he? He never relied on it.
He personally, because they couldn't get Western treatments and clinics and that sort of stuff, the story goes, he was promoting these alternative traditional medicine techniques because they were just easier to do, not because they worked.
That's the skeptic's Tim Mendham, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.